Yeah, so in previous sessions we have discussed about uh, array manipulations and array sorting, sorry, like some built-in operators, some built-in functions in array. So we'll continue those. Please wait a minute. So we have discussed the built-in function called find underscore first find, and we have discussed find underscore index. So up to here we have discussed it. Now let's start with so we have another built-in function called find underscore last. So we'll assign it to C, and let me zoom in. Wait a minute. Yeah, C is equal to a dot find underscore last with item greater than 3. Will So basically this will return the last item which is greater than 3. This is opposite to find underscore first with item greater than. So this is opposite to find underscore first function. And let me display this. Percentage p comma c. And we have one more function called find underscore last index. So let us use that also. Wait a minute. Find underscore last underscore index with uh, item greater than 1. And let us display this also. Index great greater than 1 is percentage p comma c. And yeah, so these are some of the search functions. So these are the some of the built-in functions for searching some elements in arrays. So let us run this and check the output. Let me compare it. Yeah, so let me simulate it. So this is my array 1 2 3 4 6 5 7 10 9 11, and the index value of 4 is 3. This is our previous session, and the last value which is greater than 3 is 11. So it will search from first, and the value which is greater than 3 is 4, 6, 5, 7, 10, 9, and 11. So this is the last value which is greater than 3, so it will return 3, sorry, 11. And the index containing item greater than 1 is 9. So it will search for the item which is greater than 1, and it will return the index which contains this value. So 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8 9. So this is returning 9. Wait a minute. So I've used find underscore last underscore index with item greater than 1. So it will return the last index. So index, it is starting from here: 0 1 2 3 4 5 6 7 8 9. So this is the last index which is greater than 1. So let's check this another way. We'll try to check if there is any index which is greater than 11, which is containing the item which is greater than 11. Where is this? Yeah. Let me stop the simulation. And recompile it. Yeah, here we can see index greater than sorry, it's not 1, it's 11. I have tried to find index which is greater, which containing item 11, so it is returning null. So there is nothing like that. So these are some of the built-in functions in system Verilog for searching. uh, Let us see some of the built-in functions for arrays in system Verilog. So these are all fixed arrays. So let us wait. And I have one more operator called max operator, which is used to give the maximum value of the array. So after one time unit, I'm making c is equal to a dot max and displaying it. A of max is percentage p comma c. And wait a minute. Yeah. So after one time unit, there is another operator called minimum. So it will return the minimum. Let me display this also. The value of minimum is percentage p comma c. And excuse me. So and there is another operator called unique. So this will return all the unique operators in the array. So let me display this. Sorry. The unique values are percentage p comma c. And I have one more built-in function called unique index. So I will display it also. The unique indexes which are having unique values. Actually, it's unique. Actually, it's indexes which are having unique values. So this function will return index values which are containing unique values. Are percentage p comma c. And I have one more function called. So these are some of the built-in functions, and I can have some more functions called sorting. So we can sort the array like from ascending to descending order. Sorry, from ascending order we can arrange the array. Sorted array is percentage p comma c. And we can also reverse the array by using the built-in function called reverse. C is equal to a dot reverse, and we can display it. Array c is percentage p comma c. And I have one more built-in function called rsort. So this will basically arrange the array in descending order. Sort will arrange the array in ascending order, whereas it will arrange the array in descending order. Rsort of c is percentage p, comma c. And I have one more function called shuffle. So this so this will randomly shuffle the array. So it is equal to a dot shuffle. And for performing arithmetic operations, we have some built-in function called sum. So this will basically add all the contents of the array. The value of sum is percentage p, comma c. And I have also some built-in function called product. So this will perform the product of all the contents in the array. A dot product. So let me display this. The value of product is percentage p, comma c. And I can also perform OR operation, that is c is equal to a dot OR. So let me display this also. The value of OR is percentage p, comma c. And I can also perform XOR, a dot XOR, and display this also. The value of XOR is percentage p, comma c. So yeah, so these are some of the built-in functions in fixed arrays. So let me save this and run this. Where is it? Wait a minute. I'm getting some error. Let us decode this error. So it's showing that functions with written type of void cannot be used. Is an expression 73. So okay, let me comment this. I will see why it's coming like that. So for reverse also it's coming like that. Let's see whether it okay, 83 also. Okay. So previously what we have done is no, not changed it. So, okay, let me comment this also and compile this. Wait a minute, I'm getting some errors. Let us check it. Int c of q I have declared. It's showing Cannot assign a packed type into an unpacked type. 87, 91, 94, 99. Okay. Okay. So what's happening here is uh, the value of sum will be a int type. So int is a packed type, whereas C I have declared as unpacked type. So I cannot assign packed type to an unpacked type. So let me use another variable, say int out underscore packed, and let me use it here. Out underscore packed, out underscore packed, out underscore packed. Sorry, not here. So wait a minute. Let me change here also. A dot underscore packed, and I should change here also. Out underscore packed, out underscore packed. Yeah. So let's see whether we are getting or not. Yeah. So what's happening is in previous case, the right hand side, that is a dot sum. So what will happen if we add all the numbers on the right hand side? We will get a packed number. So I will get a particular value. So that say suppose our sum value is 14. So 14 is an int type. So we are getting some uh, value 14 or 15. So that is a packed type, and we are trying it to assign to a unpacked type. That is, previously we have used C to for storing C of dollar. So this is a queue. We have discussed about this queue and what's happening if we try to assign a packed type. So up to here, that is find of x, find underscore index, that is for these operations on the right hand side, it is an unpacked type. So we cannot use packed type on the left hand side. That's why we have used C, that is C is an unpacked type. So C is an unpacked type, so we have used it in these cases. But coming to this sum, product, and or, the result will be a packed type, and we cannot assign it to an unpacked type. So that's why we are getting the error. So I have used a packed type, that is out underscore packed. Int is a packed type. So int out underscore packed I have used, and I have assigned the value. So is this clear? Is this confusing, or is it clear?
We have a question.
Yeah.
Will mean also return a pack type, or mean or max also will return a
Yeah,
single
mean
value
will
type?
also retain a packed type, because mean is nothing but average.
Mm. But where there also we are not this concept packed and unpacked will not come into picture for me.
Yeah, they will also will get that concept, right? Because mean is nothing but average. So a plus b divided by 2, we will get some packed type. We cannot assign it to an unpacked type. Is this clear?
But
Yeah.
C is unpacked right now.
Yeah, that's why I'm using another variable called out underscore packed.
Okay.
Yeah,
Yeah.
is it clear?
Yeah. Yeah. Got it.
Yeah. So if you're having any doubt, please ask me. I'll try to clear. So let me run this, simulate it. So at the console we can see OR, XOR and product. So this is how we will get the built-in functions. This is how we will use the built-in functions. So is this clear for everyone? Can we move forward?
Yes.
Yeah. So for those who are facing some difficulty with packed and unpacked type, let me show some example between how a packed and unpacked type looks like. So for packed type, let me show something, or else we will discuss it tomorrow. We will discuss packed and unpacked type in more detail, like what is this packed and unpacked type. I think we have discussed about unpacked type in our previous sessions. So if you are facing any difficulty with unpacked type, please refer to the sessions on my YouTube channel. And coming to packed type, we'll discuss it tomorrow, and we'll discuss the difference between packed and unpacked type. So for now, remember that we cannot assign a packed type to an unpacked type. It will give an error. So packed types examples are int and uh, we have bit, byte. If we use only bit or byte, then it will be a packed type. If we use if we want to use an unpacked type, then write some variable as in, not int, say bit a followed by size of the array. So it will be, so the size dimensions declared after the array name, then it will be an unpacked array. So we'll discuss these differences also, like how they are looking. So we have already discussed about unpacked type. So we'll discuss about packed type. So for now, just remember that we cannot assign a packed type to an unpacked type. If we try to assign, we will get an error. So is this clear for everyone?